So to solve by substitution, it's going to be just like that. I'm going to substitute. Remember, substitute means to plug in. So I'm going to be plugging in an equation into another equation, all right? So I think sometimes it's easier to actually do a problem and talk out the steps as we're doing one. So let's do that. Let's look at a first example here. So let's say we have the system, and sometimes they put systems kind of in this bracket, kind of like how we looked at a piecewise function. So let's say we have the system where we have y equals 6x minus 11, and we have 2x minus 3y equals negative 7, right? So when I look at this system, what we want to do is we want to pick one equation, and we're going to solve for a variable. Now, remember, I want to do the least amount of work. So if I were to pick this first equation, it is already solved for y equals. So that's going to be the easiest thing for me to do. So once I've done that, my first step, I'm now going to plug that equation into the next equation, all right? I'm going to plug it in for that variable. So what I'm going to do is I'm going to replace my y in my equation with this entire equation 6x minus 11, all right? So let's see what that might look like. So I'm going to start off and I would say negative 2x minus 3. Instead of writing a y, I'm going to write 6x minus 11 equals negative 7. So what I've done in this step 2 is I've plugged in this equation, 6x minus 11, into the variable y because that's what we had solved for, all right? Now from here, my next step is to just go ahead and solve it. So I'm going to solve for that letter x. So I'm going to do regular solving here. So I'm going to first distribute that negative 3. I'm going to get minus 18x plus 33 equals negative 7. Let's go ahead and combine these like terms. So I'm going to get negative 20x plus 33 equals negative 7. I'm going to subtract that 33. So I'm going to get negative 20x equals negative 40. I'm going to divide by negative 20. So then we see that x is 2. All right, so all of that was my third step. I'm actually solving for my remaining variables. So I see now that x is equal to 2. But I wasn't just looking for x. I need an x and a y. Remember when we were looking at where is the solution? It's the intersection point. So a point comes with an x and a y. I need both variables. So now what I'm going to do, my last step, is I'm going to take this x back to the very first equation, that I had plugged in there. And so to get y, I can now say 6 times 2 minus 11, right? I'm going to use that 2 and plug it in. So now I just simplify 12 minus 11, I get 1. So y would equal 1. So now I have my x and my y. I want to write it as an ordered pair because it is a solution, meaning it is a point where those two would cross. All right? So we're going to look at another one and go all the way through the steps again, just to make sure that we really understand those steps. So our second example, our second system is going to be negative 7x minus 2y equals negative 13. And then we have x minus 2y equals 11. All right, so there's our system. So first step, again, we want to pick an equation and we want to solve for a variable. I'm going to pick this second equation and I'm going to pick x, because if I wanted to get x all by itself, all I would need to do is move that 2y to the other side. So that's what I'm going to do. My first step, I'm going to pick x and I'm going to solve for it. So now I'm going to add that 2y to the other side so that my equation is x equals 11 plus 2y. So there's that equation that I'm going to go back to here in just a minute. Okay. So after I've solved that equation, okay, my first step, I'm now going to plug that equation in to my other equation that I have not used in place of the x. So what I'll do is I'm going to start writing my equation. -7, instead of the x, I'm going to plug in 11 plus 2y. Then I'm going to say minus my 2y equals my -13. So all I did was I replaced just this x with this entire equation here, okay? So now we're going to solve this equation. I'm going to distribute, so I get -77 minus 14y minus 2y equals -13. I'm going to combine those like terms. So -77 minus 16y equals -13. I'm going to add that 77. So I get -16y equals 64. Then I'm going to divide by -16. So y is going to equal -4. So in doing that, I now see that I've got my first variable, y equals -4. Once I've got that value, remember I'm going to go back up to where I had solved for my variable x, and I'm going to plug it in. So now I'm going to say x equals 11 plus 2, and instead of y, I'm going to plug in -4. So then I should see that I'm going to get the number 3. So x would equal 3. So now I've got my x and my y. So my ordered pair would be 3, -4. Again, I'm going to write that as an ordered pair because it's a point of intersection. So hopefully we kind of get the idea of how we're going to solve by substitution. Substitution means I am plugging something in, and that's what we're doing over and over here, right? Now, remember we talked about there were different types of solutions. So I want to show you one where I might get one of those weird types of solutions, just so you can see at which point we would see that. So let's say we had one more example here. And let's say our equation was -3x plus 3y equals 4. Then we have -x plus y equals 3. All right, so there's our system. So I start off and I say, okay, well, I'm going to solve an equation here. I'm going to pick this equation here, and I'm going to pick the y. All I would need to do is move that x, so let's do that. So I'm going to get y equals 3 plus x. So I say, okay, well, that's the equation. I'm going to go plug in. So let's do it. I start writing my new equation. -3x plus 3. Instead of the y, I'm going to write my 3 plus x equals 4. All right, so now I start solving. I'm going to distribute. I'm at -3x plus a 9 plus a 3x equals 4. Then I'm going to combine those like terms. Uh-oh, they cancel. So then I have 9 equals 4. So where's the x? I'm supposed to be solving for x, and it went away. At this moment, when the variables go away, so my variable cancels, I'm going to ask myself, do I have a true statement or do I have a false statement? Okay. So is 9 equal to 4? No, that is false. So if I have a false statement, that's going to give us that no solution, right? No solution, which means I would have an inconsistent system. However, let's say that we, at this stage, had the number 4 equals 4. Let's just say that's what it was instead. Well, 4 equals 4, that's a true statement. So if that had happened, which it didn't, but let's say that it had happened, then we would have infinite solutions, which is that consistent dependent, all right? So if the variable cancels off when I'm solving, then it's either going to be an infinite solution or no solution, and it depends on if I have a true or a false statement. Now, the most common mistake people will make is they'll end up with, say, they have 3x equals 0, divide by 3, x is 0. Uh-oh, that must be no solution. No, no, no. 0 is an answer. See how my x is still there? If my x is still there, it doesn't matter what the number is, but I have a solution. Here, my x's truly canceled. I had a positive and a negative 3x. They canceled off of my entire equation. That's when I would have a no solution or an infinite solution. Okay? So, in substitution, it's all about solving, plugging it in. Solving, plugging it in. All right? I write my answer as an ordered pair. If, when I'm solving, my variable cancels off, then I can stop and say it's either no solution or infinite solution, depending on if I have a true or a false statement, right? True statement would have been 4 equals 4. My false statement was 9 equals 4.